Now we're going to sketch the graph of y equals 1 over tan x. So that's really, we're sketching y equals cotan x. So we're going to do that right here. Now, normally I draw tan x and then I graph everything over top, but because of so many asymptotes and intercepts, it's going to look really mixed up if I try and graph that over top. So I've put another grid paper down here, so bear with me. I'm going to have to adjust the camera a few times on this one. But there's a grid paper here, so we're going to graph just y equals tan x. It's a good review anyways. I've drawn a unit circle here for us on the side because that will help us. So remember that tan x is y over x. So as we go around here, we're going to take the y value over the x coordinate. Now, I need a scale in here. We're just going to keep the first unit 1. Not that it would matter. You could space that out more if you choose. I'm going to keep each unit pi by 2, so this will be pi. So we're going to continue on with that scale there. So let's recall. So 0 divided by 1 is 0, so you've got an intercept right here. 1 divided by 0, you can't divide by 0, that's an asymptote. So your pi by 2 is going to be an asymptote. And if you think about it, now that we've learned NPVs with identities, your NPV would be where your vertical asymptotes are. So this would be x equals pi by 2. You don't necessarily need to label them all because this is just for us to get to cotan. 0 divided by -1 is 0. 1 divided by 0, so at positive 3 pi by 2, you're going to have an asymptote. And again, I'm not going to label everything here. And then you're back to 0 and 1 is your asymptote. So this pattern continues. So we're going to have an asymptote along here, which makes sense. That's negative pi by 2 right here if you were to continue using your circle instead. Negative pi, we're going to have an asymptote here. So all your asymptotes are at pi over 2 plus pi n. So then we usually had another very key point because we only have intercepts and asymptotes here, and that would be in between here. So this would be at pi by 4, remember? So at pi by 4, what is the tan of pi by 4? Well, you would find that on your special triangles. Your special triangle would be root 2 divided by root 2. We don't normally write that down anymore, but remember root 2 over root 2 is 1. So the tan of pi by 4 is 1, and it's in quadrant 1, so it's positive. So this is a positive number down here. So if we were to look at 3 pi by 4, it's got the same reference angle, so it's pi by, still a value of 1, except that in 3 pi by 4, that's quadrant 2, and tan in quadrant 2 is negative. So it's actually -1. If you were to go to this value here, that would be 5 pi by 4, which is back up in quadrant 3, so it's +1. So you're going to get this general shape here for that tan graph. So we know that pattern is going to continue along this way. So we're going to just keep that graph going. These are going to be some key points when we look at our cotan graph. So this is a review, but we don't graph this one as often, so it's good to watch this one slowly as well. So I'm going to pause or stop this video just so it's not too long, and use this picture and go graph cotan. So watch the next video to see how 1 over tan x is graphed.